Alright, this is a pre-lab video for your animated gas law lab for the combined gas law. What we're going to be doing is we're going to be looking at 4 different labs. We're going to look at keeping temperature and number of molecules constant. We're going to change the volume to see what the pressure is. Another experiment is going to be keeping volume and number of moles constant, and we're going to change the temperature and see how that affects the pressure. We're going to then keep the pressure constant and then the number of moles constant, and then change the temperature, see how that affects the volume. And then lastly, we're going to keep the temperature and volume constant. We're going to change the number of gas particles, change the number of moles, and see how that affects pressure. Okay, so first thing we're going to do is going to be our temperature and number of moles constant. Now, what you're going to want to do before you do anything is make sure that you have your constant pressure or your constant parameter on none. Alright, and what we're going to do is we're going to go ahead and just pump some gas into there. So our temperature shoots up to 300. Okay, and then we're going to change the amount to, say, 250. Well, let's go 200 just to get us going here. Alright, so 200. So there's all of our gas particles. Now, I want to keep temperature constant and I want to keep the number of moles constant. So I'm not going to change the number of molecules, so there's only 200 in there. And I'm going to change my temperature to be constant. I'm going to change my volume and see what that does to my pressure. Now, if you remember, the handle that's right here on the left-hand side of the box, you can move that back and forth for your volume. But if you're thinking, well, how do I supposed to determine the volume of this container? I can only see it in 2 dimensions. Well, I'm going to go ahead and tell you that the height of the box is going to be 5.3 nanometers. And the depth, meaning in the z-axis, the depth is also going to be 5.3 nanometers. And then you're going to determine the length of it by using the measurement tools over here on the side. There you go, the ruler. And you drag your ruler down. And you just line it up so you can get your, so you remember you want to be the inside of the container. And then you take your measurements there. So it looks like this container is about 6.6 nanometers long. So you go 6.6 nanometers times 5.3 nanometers times 5.3 nanometers, and then that should give you your volume in cubic nanometers. Alright, so we'll go ahead and do a quick trial right here. I'm going to change the volume. I want to have 5 total volume measurements in your data table. Okay, one of them needs to be between the length, because you're not messing with the height or the depth, you're just messing with the length. Okay, you want your length. You want one length to be within 4 to 5 nanometers. I want another one to be within 5 or 6 nanometers. I want another to be within 6 or 7 nanometers, which should be your first one because 6.6 is the default, and you can just use that. 7 and 8 nanometers, and then 8 and 9 nanometers. So that should be 5 measurements. So how I change this is, let's say I went to 8. Let's just go ahead and say I went to 9.6. Okay, well, let's go 9. Just go 9. 9. Okay, I need to make sure I look at my pressure, and I want to get it to the tenths place. So right now the pressure is 1.0 atmospheres. If I increase my volume to be to have my length of the volume be 9 nanometers, then I need to look at what my pressure does. My pressure looks like it's going to stick around 0.7, okay, because it's going to bounce back and forth between because of all the interactions with the wall. But it's going to back up, so we end up with 0.7 atmospheres, and you would write that down in your data table for this particular volume. Now, you have to calculate a new volume every single time that you move your container in and out. Okay. Now, if you notice, you see that my temperature is changing. Make sure, because my temperature is constant, you don't want to get your pressure measurement, okay? You don't want to get your pressure measurement until the temperature goes back down to 300 Kelvin. Okay, so you wait, and we go 0.8. Okay, so that would be keeping temperature constant and number of moles constant, and we're going to look at changing the volume to see what it does to the pressure. All right, I've reset the simulation, so now we have still 200 of the heavy species. I want to keep volume and number of moles constant now, so I'm going to click volume. You notice my handle on my box is now gone, and I'm going to change my temperature and see what it does to the pressure. So first thing I'm going to do is I have 300 Kelvin. Go ahead and write down that value. 300 Kelvin is 1.0 atmospheres. Now, I want you to get 5 total temperature changes. Okay, one between 100 and 200, one between 2 and 300, one between 4 and 500, and one between 5 and 600. So, I want to go ahead and just pick, let's go up to, let's go beyond what you need to do, and let's go up to 751. So at 300 Kelvin, it was at 1.0. Now, since my volume didn't change at all, you can see my little guy over there, he's pushing to make sure you keep the volume constant, working hard over there. We have 2.6 atmospheres for 751 Kelvin. Now you're going to do more of those. You're going to do up, you remember, 1 to 200, 2 to 300, 3 to 400, and then, 4 to 500, 5 to 600. Okay, because you're going to get 300 off the bat. All right. All right, and I went ahead and reset the situation again. We are at 200 of the heavy species again. We're at 299 Kelvin, 1 atmosphere. And let's see if we can warm that up just a tad. 300 Kelvin, there we go. You always want to start at 300 Kelvin because it just works out well that way. Now the next thing we're going to do is we're going to keep the pressure constant. Okay, so we'll keep pressure constant. Now, right now the pressure is at 1 atmosphere, so you're all at 1.0 atmospheres. So when you change your temperature and see what happens to the volume, you don't want to take any measurement of the volume until the pressure's back down to 1. Okay, so I'm going to keep pressure constant, and I want to increase the temperature. Okay, by say we starting at 300. Let's go ahead and go to 350. Okay, or somewhere around 350. Okay, so there's 350. Now, my pressure is back at 1.0. My box size didn't change from our first trial, so now we have to get in here and we're having to measure the length of the box. Okay, so it looks like he's popping out a little bit, so we'll go ahead and move him over there. Okay, now he's going to move around a little bit, so you're going to want to just do your best you can. Okay, so if he's standing still like he is right now for a while, go ahead and take this measurement, which would be about 7.95, somewhere around there, and then you would use that and multiply, or 7.95 nanometers. You times that by 5.3 nanometers times 5.3 nanometers to get your volume in cubic nanometers. Now you're going to do that for 200 degrees, 250, 300, 350, and 400. Okay, so you're going to do that for 5 collections of data. All right. So let's go ahead and reset for our last problem, or our last trial. All right, so our last trial is going to be if I keep the temperature constant and I keep the volume constant, what's going to happen to my pressure if I increase the number of moles? Now, you can only choose over in the constant parameter, you can only choose temperature or pressure, or sorry, temperature or volume. So what I want you to do is make the temperature constant, because the volume won't necessarily move with the amount of change that we're going to do. Okay, so right now, with the temperature constant at 300 Kelvin, and with 300 of the large species, we're looking at a pressure of 1.5 atmospheres. Okay, that would be your first data right there. Okay, so with 300 molecules, 1.5. Okay, and looking here, about 1. Yeah, about 1.5, because that you can even look at that hundredths place. It could round up. Okay, so about 1.5 atmospheres. Now, I'm going to increase the number of moles, or the number of particles, let's say to, just, you don't want to give a maybe no more than, yeah, that worked, say 335. Okay, actually, you know what, let's go ahead and go, so you're going to go 300, 350, and then, remember, you want to make sure that your temperature stays constant, and your, once your temperature goes back to 300 Kelvin, then you can take your pressure measurement, which would be 1. Looks like everything's staying above 1.65, so you say 1.7. Okay? And I want you to do that for 300 number of molecules, 350, 400, but I also want you to do it for 250 and 200. So 200, 250, 300, 350, and then 4. Okay? So there's your 5 measurements there. Okay? So, just to review, you're going to have 4 different trials of this experiment. Or sorry, 4 different labs of this experiment. One is going to be keeping temperature and number of moles constant, changing the pressure, or changing the volume to find out the pressure. And then you're going to have keeping volume and number of molecules constant. You're changing the temperature to see what happens to the pressure. You're going to keep the pressure and then the number of molecules constant. You're going to change the temperature and see what happens to the volume. And then lastly, in this example, we're keeping temperature and volume constant. We're changing the number of moles to find out what happens to the pressure. Okay? Now, you have a data table that is on the table of contents. Please make sure you print that out. Understand that you're going to actually be doing this twice. You're going to do all 4 of these twice. You're going to do one with the all 4 of those experiments with the heavy species with the same number of molecules. Okay, and I'll tell you how many molecules to start off with. If you need me to. And then you're going to do the same 4 with the light species as well with the same number of molecules. Okay? If you guys have any questions, please ask me before we start the lab tomorrow.